I think we're on. So welcome everyone to our 7th episode of Prodigious Kentuckians. As always, we're on YouTube and a variety of podcasts out there. I'm your host, Trent Garrison. Julie couldn't be with us tonight, but she'll be back next time. Tonight, our show is on science organizations in Kentucky. I'm very excited about this. I'm a scientist myself, and we have 6 very knowledgeable guests joining us, and I'm excited to hear what they have to say. Some of them I know, some of them I don't know as well, so I'm want to know more about their organizations. So I thought the best thing for us to do is to give each person a minute or so to introduce themselves and to tell us a little bit about their organization. So if you guys want to go ahead and jump on now, we'll get started with that. But what I'm going to do is I'll start out myself, since I am one of the people on here representing a science organization. So I am Trent Garrison. I did my bachelor's and master's at Eastern Kentucky University. I did my PhD at UK in geology, and I am here to represent the Kentucky Academy of Science, where I'm the president. So just to tell you a little bit about KAS, it's a large interdisciplinary organization in Kentucky made up of, 4,500 scientists, students, academics, industry people, basically anyone interested in science. We have a really good executive director, Amanda Fuller, who does just a terrific job of managing everything going on. KAS does a lot of stuff, so she does a really good job of keeping us online. And our mission is to foster scientific discovery and understanding in Kentucky. So KAS does a variety of events, everything from hosting an annual meeting. We have really good speakers there. We have grants for students and for early professionals. We have a speakers bureau. We host the Junior Academy of Science. We track legislation and do quite a few other things. And to learn more about Kentucky Academy of Science, you can go to kyscience.org. So that's my brief spiel on KAS. And with that, let me pass it over to someone else. And as we go through this, just introduce yourselves, talk about whatever you want to talk about, and your organization. So I will pass it to the next person on my list, Ms. Glover.
Hi, I'm Kaylene Glover. I'm currently a PhD candidate in the UK Biology Department. And I am here representing the Kentuckians for Science Education organization, which is having a revival of sorts. It's been around for a while, but hasn't been very active in the last few years. And so we are kicking things off with a variety of new projects. I think some people have already mentioned our website. I know it needs updated. I'm working on it. But while I've only spent limited amount of time teaching, science education has always been the big passion that's driven my life. I had a really influential high school biology teacher. And I was like, I want to be that for someone else. And I just felt like my classroom was never big enough. And so I've kept going on trying to find new ways to reach the public and bridge gaps between the scientific and usually religious communities. So I work with a variety of different ideological constructs that tend to have issues with science. So that's my big passion in my life, and that's who I represent.
All right, thanks you for sharing. I will just go down my list. Dan Phelps is the first person to be on twice, so welcome back, Dan.
What an honor. I volunteered to be Ed McMahon to your Johnny Carson, but I guess that one fell through. I'm Dan Phelps. I run the Kentucky Paleontological Society. We're a group of not only amateur fossil collectors, but also people that have a good scientific background and want to learn about science, not just collect things. We typically, before COVID, we had monthly meetings and monthly field trips. We usually skipped January for a field trip, but in February, we usually would go to the Cincinnati Museum Center and look at their research collections. But of course, that is sort of on hold right now, but I'm proud to announce we will soon be having our first meeting via Zoom on January 29th, and Amanda Fuller from Center College is going to give us a talk. She hasn't given me the topic yet, so we haven't gotten the newsletter out. But in any case, we are very much involved in paleontology. We've sponsored several pieces of scientific research with things we've actually discovered on our field trips. I brought along a couple of fossils. Trent said that we might want to do a show and tell. One of these is a very large Edrio asteroid found on a firm ground from the Borden Formation out near Radcliffe, Kentucky. We discovered this fossil as both a new genus and new species way back in 2001. And the paleontologist Colin Summerall actually described this and did a paper in the Journal of Paleontology on this new, very large species of lower carboniferous Edrio asteroid. It's a type of echinoderm. It looks a little bit like a starfish sitting on a disc, but they're in a whole extinct class of echinoderms. Also brought in one of my passions is a type of fossil sponge called Brachiospongia. Brachiospongia is sometimes nicknamed the elephant foot sponge. This is an exceptionally small specimen. Back in the 19th century, more than 100 of these were found in the Frankfurt area. And I spent a lot of time trying to go back and find new specimens. And ultimately, I found a large number of them around Danville in a place in a rock formation called the Curdsville member of the Lexington limestone. But anyway, I plan to eventually do research on these and publish on this particular fossil. I have quite a few specimens of it now, even though it's considered a rare fossil sponge. So in any case, I really hope people will consider joining the Kentucky Paleontological Society. Our website is listed next to my head here. And we also have a very active Facebook page. If you're on the Facebook page, you're not necessarily a member, however. You just get to read some of the details about meetings, but you don't get invited to field trips unless you're an actual member. So anyway, the contact information is right next to me here, and I think that's all the time I should take up from Trent. Thanks, Trent.
All right, thanks, Dan. Next on my list is Miss Kleinmark. Am I pronouncing your last name correctly?
Yeah, Kleinmark.
Okay, all right. Go ahead.
I'm Megan. I am currently the president of the American Institute of Professional Geologists, or AIPG. I have my bachelor's degree in geology from the College of Charleston in South Carolina, and I have a master's degree in geosciences from the University of Montana in Missoula, Montana. I moved to Kentucky about 9 years ago, and I've been learning ever since. I became involved in AIPG several years ago, but have been actively involved in recent years, thanks to Trent, actually. So AIPG is an amazing organization that advocates and is dedicated to the profession of geology. So really just trying to get people interested in geology, and not just interested, but working as geologists. It's a really incredible organization for many reasons, but we as our Kentucky section really try to focus on community outreach, specifically to our local colleges and universities, and trying to get students excited about geology and wanting to get into it as a profession. So we also work very closely with the Kentucky Geological Survey and the accreditation agencies to try to get students to become accredited and stuff like that. We run technical workshops. A lot of this, of course, is pre-COVID time. So we're still trying to figure out what we're going to do this year for our kind of research and outreach and stuff like that. And yeah, so.
All right, well, thank you for being here. Yeah, science and engineering for a long time has been a white male-centric population, so we're trying to change that, hopefully. So yeah, thank you. Let's see, next on my list is Mr. Goff.
How's everybody doing tonight? My name's Patrick Goff, and currently I'm the past president of Kentucky Science Teachers Association. I was the president a year and a half ago. Our terms had to change up a little because of COVID and other things were going on with the organization, doing some reorganization within KSTA. But I've been active in KSTA now for 9 years. My friend David Helm, the science coordinator for Fayette County Public Schools, kind of tapped me on the shoulder, said, "Hey, I think you might be good to be on the board of KSTA." And I'm like, "Sure, sounds like fun, David." And 9 years later, now I'm here. But I have a bachelor's in science education, earth science from Edinburgh University in Pennsylvania, and a master's in administration, and I'm nationally board certified as a teacher. So our goal for KSTA, we're about 400 members strong right now, hoping to grow our numbers. But our main goal, to be honest, is to help move science education forward within the state of Kentucky. Our goal is to help teachers become better equipped to help our youth learn the process of science, not the old scientific method, if you will, but learn how science is done, who does science, and just the wonderment, the joy, if you will, of doing science. So our big activity is we do a annual conference. Obviously, we didn't have one last year, but we've pushed into February of this year. So if anybody's interested, February 26th and 27th, you can come to ksda.org and sign up to come to our conference. But we are not an organization that's strictly just science teachers. We're trying to break out of that and take it more in a direction of people who are interested in science education. It doesn't have to be in a formal public school, K-12 school. We're hoping to bring more people into the fold, because that will just help all of us out. So I don't know. I just got interested in science because I think it's, Kaylene, I think you said you had the teacher in high school that really, made an impression on you. And that was, I knew in high school, I loved science. I was a Boy Scout, so I liked working with people. And my mom goes, "Hey, why don't you teach science?" I went, "Oh yeah, that'd be cool." So, so, 19 years later, I'm still teaching. So it's fun. I love it. This year has been a blast. Trying to teach science virtually. So, but yeah, come to ksda.org, learn more about our organization. We have a Facebook page, Twitter account. We're finally getting onto social media. I think they're trying to figure out if we can get into the Instagram phase, but we'll see what we can do there.
Well, thanks.
That's probably enough for me.
We're glad to have you here, and I look forward to working with you in the future as we were
absolutely.
Yes. All right. Next is Dr. Cagney Elena. So we're happy to have you here as well.
Hello. So my nonprofit's name is Nerd Squad. Nerd Squad is a STEM nonprofit that targets girls of color. We take high school girls of color, and together we collaborate and we design and develop these interactive STEM activities. And then the high school girls go out into the community and they become the experts and they facilitate the activities and become the mentors. It's kind of like a bridge program. It's like us actual scientists mentoring these high schoolers who are interested in science, and then those girls going out into the community and becoming the face and then mentoring these little kids. And it's all about changing the way or what a scientist looks like. I mean, I'm a molecular biologist by trade and I actively do science, but I was probably 2 years into my career before I ever seen a scientist that looked like me. That's the problem. And when I would ask, why don't I see more scientists that look like me? People would tell me that people of color weren't interested in science. They don't excel in science. And when I go out into and I'm like, well, I'm a person of color. I excel in science. I'm interested in science. When I go into my own community, I feel like it's an exposure issue. They don't get the mentoring. They don't get the exposure. You can't dream about the stars if you've only ever seen a dark, cloudy sky. Like, how do you dream about something that you're never exposed to, that you never get to see? How do they know that's an option? How do they know that they could grow up and that could be them? And so we create an environment that is conducive to critical thinking and learning, but at the same time, we take science and we create environments where kids can draw a straight line to the science. Like, last year, we took our middle school girls and we turned them all into biochemists, and then they got to design and develop their own makeup products. And they created their own product lines. They learned about the chemistry of makeup and cosmetic chemistry and what you have to do to become a cosmetic chemist and all of these things. But what middle school girl doesn't know about makeup? And how many of them ever thought about the fact that it takes a scientist to develop these products and for you to use them? Probably none of them. But by giving them these opportunities and creating these connections, we actually build this confidence, and we give them these exposures that they need to actually think that maybe this is something they can have as a career. I mean, because really, what fun is it to be a unicorn? That's why you never see them, because it's not fun. They're always in hiding. I don't want to be the only one in a room. I think that in all spaces, there should be multiple diverse people. It takes a lot of different minds thinking a lot of different ways to be innovative. And as Americans, we're not very innovative because everybody looks the same. Everybody has almost the same life experiences. They're all bringing the same things to the table. And so we need to change that. And that's what Nerd Squad was. That's what I designed Nerd Squad to do.
Well said. Well, thanks for being here. We appreciate you sharing that. Let's see. Dr. Dave Robinson.
Yeah, hi there. I'm Dave Robinson. My organization is actually just a radio show. There's a local community, all volunteer radio station in Louisville, Kentucky. It's WFMP 106.5 on your FM dial if you're ever in Louisville. But we also broadcast our show on SoundCloud and iTunes. But the show's called Bench Talk, The Week in Science. It's like a news magazine for science. It's a group of us scientists who report on all aspects of the natural sciences, the social sciences, engineering, math, technology. We also try to cover science policy and science education. And basically, we're just trying to bring science to the people, make people realize that science isn't as hard or boring as they thought it was. And I think the pandemic did a pretty good job of showing that. But so it's really neat. It's a half-hour radio show on every week. We have a Facebook page. Just do a search for Bench Talk, The Week in Science, and you can hear our previous episodes. We've been on a couple years now.
Yeah, it's a great show. Yeah, thanks, Dave. So, first of all, it's an honor to have such a great bunch of scientists on here. What I would like to do now, as we talked about a little bit earlier, is if folks brought something cool with them, Dan kind of gave us a little hint of what we're going to talk about next, but if folks here brought, whether it's a fossil or whatever it is that has a story, maybe you don't have a story, maybe you don't have a fossil, maybe it's just like a story that you have that got you interested, or something along your career path that's interesting to share, feel free to do so. That's what we're going to do next. So I guess I'll start with this to give you an idea of what I had in mind. We'll spend a minute or something on this too, and then we'll get into questions. I see some people posted questions already about the organizations in the chat. So this is a garnet. Garnet's a really cool looking mineral. So if you're a geologist and you're getting ready to graduate with your bachelor's degree and you're planning on going to graduate school, what you're required to do, at least in most schools, you're required to go on a 6-week field camp somewhere. And a lot of times the people in the East will travel out west of Montana or Utah or something like that. And we'll meet people from all over the world, and we'll spend 6 weeks cramped up in very close quarters with a lot of people we don't know, but all we have is just common interest. And, every day, except for Sundays, as the way my field camp worked, at least, every day except for Sunday, we're in the field from, 7 a.m. to 7 p.m. every night, just working our asses off, trying to map and doing hydrogeology projects and, things of that nature. So my field camp, we went through Arkansas. Was it Arkansas State? Some Arkansas State. It's been like 20 years ago. And we took, I think it was 5 20-passenger vans. It was like huge vans. I don't even think they make them anymore. But, you get to know people very, very well. So we drove out there and did all kinds of cool things. And on our day off, we got to, on Sundays, we got to do whatever we wanted to do. And there was usually sponsored trips to these old mines. And we, being from Kentucky, and at that point in my life, I hadn't really traveled as much. So they took us out to this mine. Most of the rocks we see around here are like gray, or the same color. They look the same quite a bit. So get out in Montana and you have malachite and azurite and all these, blue, green, all these different color, red, all these different colored rocks and minerals that you can dig out. And it was just like, this amazing thing. So we got this garnet here and brought it back, and a whole bunch of other stuff. So I thought I would just share the story from that one. So does anybody want to go next, or do you just want to go down the list like we did earlier? Anyone want to volunteer to go next? I will pass it, since nobody's saying anything, I'll pass it to Dan then. He started talking about his a little bit earlier.
Oh, I'm so sorry I goofed up earlier, Trent. I have to bring on something else. I always carry a meteorite with me. Let's see if I can get it to show up on the screen. There we go. It's a Campo de Silo iron nickel meteorite from Argentina. These were found by the Spaniards. Well, actually, they were found by the native people originally. And they all claimed that it had fallen from the sky. Most people didn't believe them until much more recently. And unfortunately, the Spanish, when they found it, they originally thought it was all going to be silver. And it turned out to be just a massive iron deposit. They pretty much ignored it. But it turns out this is the core of a protoplanet that didn't form completely. And it's about 4.5 billion years old. Meteorites are particularly interesting because they're just the building blocks of the planets in the early history of the solar system. And I love collecting them. I'm unfortunately unable to find any myself here in Kentucky, although there have been several falls here. But some of them are still rather inexpensive. And if you're interested in meteorite collecting, tell me. I'll try to put you in touch with some people. And I'm on the UK Astronomy Department's list of people to contact if you actually think you might have found a meteorite. In more than 20 years' time, though, I've only seen pieces of glass slag and stuff that wasn't a meteor, mostly meteor wrongs, unfortunately. But anyway, I thought I'd mention that since I already did my show and tell. I'm embarrassed. But anyway, pass on to somebody else, Trent.
Do you tell them that it's a meteor wrong when you
yeah. The worst story was this woman that was from down around London, and she claimed she saw a meteorite land in her backyard, and she went out and collected it, and I had her bring the specimen to a Paleontology Club meeting. And when she gave it to me, it was a stream-rounded piece of chert that you can see crinoid stems in. And I felt so bad when I told her it wasn't a meteorite because it was the saddest expression I've ever seen on a person's face in my life. You thought I would just kick the puppy in front of her or something. It was so sad. But these things do happen from time to time, and sooner or later somebody will bring me a real meteorite.
Yeah. Well, thanks for sharing that. This is a good time to mention if anybody has any questions, feel free to post them in the chat, and we'll try to get to those before the end of the show. All right. Thanks for sharing. We'll go to Megan next.
Okay, so I have a late Cretaceous Ammonite. Dan, what species did you say this was?
I'm not sure of the species, but it's probably the same family as Hoploscophites. It's a scaphidid.
Awesome.
And they're probably
but anyway, I found this in eastern Montana in a place called Fort Peck. And along Fort Peck is a formation called the Bear Paw Shale Formation. And that formation goes along eastern Montana and even up into Alberta, Canada. And this formation is made up of shale. And within the shale are these large nodules. And the nodules, I should have printed out a picture of the nodules, but they can be anywhere from this big to just gigantic. And it's really fun because you go and you take a rock hammer and you crack open the nodules, and in just probably about 90% of the nodules is a fossil in the center, the nucleus. So nobody really knows how these nodules formed. However, the Bear Paw Shale Formation occurred along when there was like an intercontinental seaway in that area. So it was a very shallow marine environment. And you just have tons of these little fossils. So it's really fun to take your rock hammer and you just crack it open and you see what is in there. Well, imagine my just glory when I found this inside of it. And it's my most favorite thing I've ever found, I say in the wild ever. because it still has the original pigmentation of the Ammonite. And yeah, it's very special to me. And I was out in Fort Peck, actually. This is a great place to talk about this quickly. When I was in graduate school, my advisor was part of this group that was trying to conduct outreach to teach science teachers how to teach science. And so we went out there to lead these middle school and high school teachers and basically teach them about deep time. And that area of the world is really great to do that because there hasn't been any sort of deformation. There's no, around here we sometimes have, faults and all that kind of stuff. And there is that out there to some degree, but it's just very layered. So it's very easy to see this is from this time, this is from this time, this is from this time. Anyway, I'll pass it along to somebody else.
That's really cool. Patrick, you're next. It's switched around on me. You're next.
Well, I don't have any cool things with me like that, so I'll just tell a little story. I've been a science teacher, and I do love teaching, and I love science. So I'm glad I was able to marry the two and be able to teach science for a living. It's been a blast. I've been in middle school working with 13 and 14-year-olds now for almost 19 years. So it's something new every day. But the story I'd like to tell you is about 7-8 years ago, the state adopted the next generation science standards. And it's a whole new set of standards in how we teach science. And they went about and reshaped where some of the content is put, grade levels. We rebanded some of them. We regrouped some of the standards. There are people that will argue that we've gotten rid of some things. We haven't. It's been embedded with other things. We're trying to take the silos out of science, if you will. It's just chemistry or just physics or it's just biology, because if you're in biology, you're going to need to know some chemistry to be able to do the biology. And we're trying to show how we're integrated more that, and we're really getting into the process. And so with these new standards, our organization, KSTA, has been helping our teachers in the state learn more about it, about how to implement it within the classroom. One of the big things you'll hear with these NGSS is called three-dimensionality. You have one pillar is the content, okay? Another pillar is called the science and engineering practices. And then we have what's called the cross-cutting concepts. And they're the big things like the arch is that it doesn't matter what branch of science and you're going to do it. So it's really neat. It's been interesting that I've been able to be in some of the ground floor of some of that stuff here in the state and helping our organization grow and how to show to other science teachers around the state, this is how you can do it. This is how you bring it together. Yeah, you've got your old ideas. Now let's see, how can we take it and actually add those other two dimensions onto your activity, and not just, weekly bringing in, but how can we actually make it a three-dimensional activity? And that's been very, very fun. And I mean, it's a headache when you really start thinking about it, but it's that good headache, if you will, because you're really thinking about it. It's really cool to see those neurons fire off. And it's been fun as an organization to work with people and see the light bulb, like, oh, that's how you do it. Okay. Then they take it back and it organically starts growing out from them then. So one of my goals, and if you'll indulge me for a minute, but one of my other goals now is with the organizations. I've been the last 4 years been working on how, and I love that you all are here because you've already given me ideas, but how to bring scientists into the classroom to work with my kids. And I started out on, I don't know about you all, but I avoided Twitter like the plague for the longest time because I thought it was stupid. But then when they said, hey, there's a bunch of scientists on there, I said, really? So I got on Twitter and started talking to the scientists. And so for the last 4 years, I've been able to bring through those relationships, if you will, and contacts people into Zoom and Skype in with my kids. And because of that, I got invited to the Society of Conservation Biology, the Marine Division conference in St. John's Bay, Canada. talking to the president of that organization, she invited me up there to come present about how I'm bringing the scientists to work with my kids. She's like, our people need to hear how you're doing that so they can go out and work with other teachers around. And so that's taken me on a whole nother angle. Now I'm working with an international science organization. And personally, I still keep laughing that I'm part of a marine science organization in the state of Kentucky that has no ocean near us. So I always laugh about when I start thinking about that. But I've been trying to bring that into the organization as well to show people like, look, it may not be the content, but it's so worth taking the time to let these kids see scientists, a huge diverse field of scientists that are out there. So maybe they can see somebody like them or go, hey, they got a similar backstory to me, and they're doing science. That's awesome. So maybe I can do that too. So that might have been longer than I meant to take, but thanks.
Oh, that's all right. We're doing well on time. Yes. Thanks for sharing. Cagney.
So I didn't have anything to show and tell you. The molecular biologists really don't have like cool trinkets. We just
That's
have
fair.
DNA and RNA. And you can't really see those with the naked eye, so I couldn't really bring that to show you guys. But since Patrick was talking about marine science and stuff, I'm gonna tell you guys how I became a bench scientist versus a field scientist. So like the whole time I was growing up, I was dead set that I was going to be a marine biologist. I had it set in my mind. I watched every Discovery Channel, every National Geographic. When I got in the bathtub, I would like pretend like I was in the ocean. Like I had it. I was ready. I went to Kentucky Kingdom and got in the wave pool a lot. So I knew how to handle the waves. I had it down pat because, you have to improvise when you live in a landlocked state. But I also didn't grow up like going places. So I never really saw an ocean either. So in my mind, what the ocean was like was really absolutely nothing what it was like the first time I ever seen an ocean. So I went to college and I was like, my major is going to be marine biology. I'm going to study great white sharks. I got this. This is what I'm going to do with my life. And then the first time I ever got pushed in the ocean, I was like, oh, you can't see the bottom. It's really dark. My body actually isn't equipped to survive out here in this ocean. Now I'm at the bottom of the food chain. Things seem a little different. So I went back to campus and I changed my major to biology because clearly I didn't want to spend the rest of my life at the bottom of the food chain for a career.
There you go. Yeah. Thanks for sharing. Dave.
Yeah, how about a little history for my show and tell? What important events in science and technology happened today, January 13th, 1854? The first patent for the accordion was issued. There's a little bit of musical technology. On this day in 1928, the first telephones, the first televisions were put into people's homes. It was in New York State, and it was 1.5 inch by 1.5 inch television, 1928. 1957, well, there was these people from this company called the Whammo Company. They were hanging out near a pie company, place that was making pies, and the truck drivers were tossing the pie plates around. On this day in 1957, they conceived of the idea of the flying disc, and the pie company was called the Frisbee Pie Company. And so today, the Frisbee was invented. And then finally, on this day, January 13th, 1958, Linus Pauling, one of the most famous chemists, he won 2 Nobel Prizes. He presented a petition to the United Nations to ban nuclear weapon tests. And there is a petition signed by 9,000 different scientists. 5 years later, the Soviet Union and the United States did come up with a nuclear test ban treaty. All started today.
Interesting stuff. Let's see who's left. I can't see in my view. Kaylene. Yes, Kaylene. There you are. Yes.
So I'm a biologist, but I specifically am an ecologist and evolutionary biologist. And it's, sometimes like I have some like things that are unrelated to my research, and so I don't show them because I specifically study human evolution, and specifically in the field of reproductive behavior and why humans are the way we are. And what I want to tell you is I'm going to illustrate Cagney's point about the importance of representation in science through my research. So one of the things that my research touches on is the development of secondary sexual characteristics, which is the term that you use to describe various traits that are used to try to attract members of the opposite sex. Okay, so that's, it boils it down pretty simply. So for a long time, and still is today, in fact, if you look at the literature, the predominant opinion is that human females and the classic hourglass shape evolved to attract males. Now, there's a few problems with that. Number one, we are a female choice system. For every one female that's reproductively available, you have between 7 and 12 males, okay? We don't have to worry about attracting males, but primates are strongly driven by female intersexual competition, which means we fight each other all the time, and social hierarchy matters, and control of resources and so forth are all a component of that. So that's played a much bigger role in human evolution than women attracting males. But their arguments are all based on things like breasts are attractive, butts are attractive. I'm like, according to whom? You are a Western male. You are, and if you look at globally, universally, breasts are only considered attractive in about 7% of the world's cultures. And those are specifically tied to those that have suppressed breastfeeding. You make something taboo, it becomes something that is attractive, right? That's how fetishes and so forth actually evolve. And so this conception that has driven the dialogue when it comes to humans and our behavior and our very bodies is based on a view of women as being something for men, when that is absolutely not the case. And why do women have like relatively wide hips and breasts? Child care. Because our ancestors had chest hair and offspring would cling to their chest hair while nursing, right? We don't have chest hair. And so what they do instead is they ride on your hips. How many times do you see a mother walking around with a kid on their hips? Additionally, the breast structure changes that happen along with pregnancy and lactation are specifically designed to be flexible so that the child can access the breasts, and anything that looks, in fact, the classic, like the exaggerated hourglass shape is indicative of negative reproductive fitness. Like that is not somebody who's actually going to be able to have offspring, carry them for long periods of time, or nurse them, because that indicates there's milk storage problems, right? So these ideas are all based on a specific idea that women are something to men in a very specific culture. And this is still one of the, it's annoying how common this particular misconception is, even among biologists and people who study this work.
Well, I attended one of your talks one time, so I knew it would be interesting.
This is why, like, when it comes to my research, I don't always go out in the public and talk about it, because it can be like an interesting conversation. Like I will either start a conversation or I'm going to end it. Like it's one or the other. There's no in between.
That's right. That's right. Well, we appreciate you all sharing that. Yeah, I as we were going through this, I thought maybe I should have shared my story about the first night on field camp when some guy got stabbed with a beer bottle, but in the chest. But I didn't want to scare anybody away from going into field camp. So we had an interesting. He's fine. He's fine. It was like no big deal. But you never know what you're going to run into in rural Utah. That's the moral of the story. So anyway, if anybody has any questions, post them in the chat and we'll get to them. I'll ask a question then from the chat, and then I have a question of my own. Melissa asked, how do we support Nerd Squad? First of all, answers questions for Cagney, I suppose. Do you like I don't know, it means like donations or?
Well, we always need donations and volunteers. We have a Twitter, a Facebook, Instagram, any other social media you can think of. You can follow us and find us at Nerd Squad Inc. Right now, we have a project going on called the Tap In Project. And so basically to combat the fact that kids weren't going to school and they needed things to do at home to facilitate at home science, we developed these kits where we basically give students everything they need to tap into their inner scientists. So they get a lab coat, they get goggles, they get beakers, test tubes, they get a faux scope, petri dishes, and all kinds of forceps and stuff. And then we design and develop these manuals. And in the manuals, 20 to 25 experiments that they can do at home, that all the materials cost less than $20 or could be readily found in their refrigerator. And so we've been passing those out to students in the community in Lexington and giving them away to different schools and stuff. So that's the initiative we've been working on during this COVID craziness.
All right. Yeah, great. Understand. So a question I have is something we were talking about a little bit earlier on the pre-show, if you want to call it that, is how do we work together better in the scientific community to, I don't want to use the word educate because I feel like that's pretentious, to spread around scientific knowledge and work together better, give people resources that they want and need, but don't know where to go to find it. Anybody want to jump in and have any ideas on that?
That's a tough one.
I mean, I could say that part of the issue isn't so much that people don't know how to, that they don't know that there are resources that are out there. It's finding quality resources, and it's finding things that can make sense of the biology in a way that doesn't talk down to them, while at the same time isn't completely inappropriate. As some of us might know, scientists are not always trained to teach science. Working with the public, breaking highly complicated ideas of really specialist areas down to lay language that they could explain to like an 8-year-old isn't something that they regularly do. It's not what scientists are trained to do. And so I think a part of that is just, helping the public get a basic level of what science is, what it is not. We were talking about this earlier, the scientific method, and how it is not at all what people think it is. I think COVID has done a lot to sort of expose misconceptions about the scientific process. And that's been kind of exciting to watch. But so there's the translation side, and then there's the ideological conflicts that people have. If they think that science is going to present something that's a threat to them and what they believe, then that doesn't really incentivize them to explore science. And that's really tragic because science is available for everyone, no matter what you believe. And I think that there's a lot of value that can be gained by bridging those gaps and helping people not be so frustrated. Science can be kind of elitist, and it will really push people away who feel like they don't belong, and that includes religious people. So I think bridging that gap is really important work for that.
Yeah, absolutely agree. A question I received earlier, just before the show, was, where do people go to get resources? And that's a very broad and general question, but I guess the answer to that, and please feel free to chime in, is that, it depends on what it is specifically. For example, if you find a fossil, Dan could help you out with that. You could go to Kentucky Paleontological Society. What if you find something on your property? What if you find a rock that you think is a meteorite? A lot of people contact colleges and contact college professors, or the Kentucky Geological Survey. We only have a couple minutes left, but what kinds of what kinds of questions do you guys get outside of geology and paleontology, outside of physical things that you find they bring to your office and want somebody to identify it? I guess maybe Patrick or Cagney or somebody else, Kaylene, maybe anybody else. What kind of questions do you guys get on a regular basis?
I get a lot of questions on vaccines, climate change, evolution. I actually, part of human reproductive
GMOs.
behavior. Yeah, GMOs. A lot of reproductive behavior includes sexual coercive behavior. And so I've, because I got kind of frustrated with having to say the same things all the time. And so I actually added to my professional website a section on here's a boilerplate on how vaccines work, and here's some links. And that way I didn't have to keep going to it, and I could just share that with people who asked. And so just explaining the science in a way that's accessible, and it's all kinds of science. And if it's not something I know, I'm I got to go brush up on my molecular biology, or I'll ask Cagney.
Yeah, I get a lot of, well, do you believe in that? Okay. And you all can correct me if I'm wrong, but I would tell them it's not that I believe in it, it's that I understand the science behind it. I understand the process, how they came to where the understanding that we're at right now in evolution or climate change or, whatever field it is. And it's I understand the process. And so if I understand that process, then I can trust the results that we're at right now. And you know what? In a few years, it might change because we discover something new, we get a better understanding of how it works. And that's why I love science. And I know, and I'm sure you all got it too with this whole COVID. It was like watching science in real time. And I think that was blowing a lot of people's minds. But they said this 2 months ago. Yeah, well, we didn't understand this then. Now we do. That's why we're changed we've changed directions, if you will. This is science in real time, folks. I think it was blowing a lot of people's minds.
I'm going to piggyback off what Kaylene was saying. I think that, at least in my community, it's a trust thing. It isn't, I feel like a variety of scientific questions because people trust me. And people don't really trust scientists. Scientists haven't really done a lot of trustworthy things over time. So why would they? It's very understandable. Scientists don't actively do things to build back community trust either. So it's even more understandable. And so where I fall in all of it is usually the person people trust. And so they know I'm into science, they know I'm a scientist, but they trust me as a person. So they ask me questions that they know the answer to, but they just want to know, do I say the same thing, just because they trust that if I say it, people will literally ask me questions that end with, well, since I trust you, I guess I believe it. Even though I didn't say anything different than what they already know.
That's a really good point. We had that conversation the other day, some science friends and I did, and somebody brought up, we're talking about climate change, and somebody said, when's the last time you heard somebody talking about climate change with a Southern accent? The South, where, a lot of people don't accept climate change. So I thought that was an interesting point.
Yeah, I agree with Cagney. It seems like people I talk to, their primary source of information is Dr. Google or Facebook. They read stuff on Facebook, and then they'll ask me, hey, is asparagus, if I eat asparagus every day, I'm not going to get cancer, right? And I'm like, well, asparagus is good for you, but no, it's not going to totally prevent cancer. So people have too many resources. It's not like they have nowhere to go. They go to places that are unreliable.
Yeah, I always hear stories about people that put their kids in front of YouTube that might be interested in astronomy, for example, and they're watching videos from NASA and various planetariums, and then they come back half an hour later and the kid's watching a flat Earth video. There's just so many things out there that are misleading the public as to what science actually is. And that's basically, I think, some of our different organizations' major task is to try to correct all these misunderstandings and misgivings that are in part our fault. As Cagney said, people don't trust us because we have a horrible history. You have to look at the different medical experiments, the Tuskegee syphilis experiment, stuff like that. And it's no wonder people don't trust us. Being a Kentuckian, at least my Kentucky accent sometimes helps on things like climate change, as I think Dave said. They are used to somebody that sounds like a damn Yankee talking about climate change. And the people they trust are people that are often fundamentalist types, or people from the South that are very much against science. And when they hear a person with a Southern accent actually speak up in favor of climate change and other sciences, sometimes it might help a little bit. I think that's one reason I was picked for the documentary I was in, was my Southern accent and the fact that I'm from here in Kentucky.
And I'll add a note on that. One of the biggest things there's the regional, the group identity that plays a big role, because there's this automatic trust that's formed. There's also the like religious side of things. So a lot of times, if you can find a religious leader or a religious organization that has a statement on a scientific issue, that can help people build trust that that's not something that's going to send them to hell, for example. I grew up, so by the time I left high school, I was a very conservative young earth creationist, and very religious. And that's all changed. It's the religion has been the thing that I have been most involved with. But I think we discount religious leaders as sources of scientific, I'm trying to have a good word for it, but trust. And if we can, I think one way that scientists can help is to work with religious leaders and help them sort of work through some of their things, and then they can work with their congregations.
All very good points. Well, I want to thank you all so much. We're running a few minutes over, and I appreciate your time very much. Very happy to have this panel. And there are many discussions that we could just go on and have an entire different show on. Really interesting stuff. So this has been very informative. And anyone out there listening, I will just offer up, since we didn't really get into it too much, if you have any specific questions, if you want to reach out to somebody or try to find the answer to some sort of science question that you are searching for, feel free to reach out to me and I can try to put you in touch with the appropriate person. So I want to thank everybody very much for attending, whether you're watching online, you're listening on the podcast, on YouTube, or whatever it may be. I also want to thank our guests. So thank you very much, and you have a wonderful evening, everyone.